we are going to delve deep into the topic autonomous vehicle, a critical reflection. We'll examine the social impact, ethical dilemmas, and sustainability challenges of self-driving technology. My name is Yubraj Sharma, an undergraduate student at Alliance University. So the topics that we'll be covering is topic selection. First, we'll be selecting a topic which is autonomous vehicle, and then we'll go for social impact analysis. And then we'll dive into ethical and sustainability trade-offs, after which we'll move on to personal reflection. And finally, we'll end the topic with product lifecycle assessment. Let's go on with the first topic, which is topic selection and why autonomous vehicles matter. In the engineering domain choice, autonomous vehicles represent one of the most significant engineering innovations of our time, promising to revolutionize transportation while raising profound questions about safety, equity, and societal values. This technology sits at the intersection of artificial intelligence, mechanical engineering, and social policy. Talking about the technological promises reduce accidents, increase mobility, and optimize traffic flow through driven system. The critical questions here is that who controls the technology, who benefits, what values are encoded in life and death decisions. And you can see these are the reference images that I've taken from Google. uh, these are the autonomous vehicles, right? So let's move on to the next topic. So social impact and who benefits. Let's check. Wealthy primary beneficiaries. Okay, so wealthy people are the primary beneficiaries. $100,000 plus income requirement in urban geographical bias and 24/7 service access. These are the basic features we can talk about social impact, right? So who benefits? Early adopters gain significant advantages from autonomous vehicle technology. Affluent urban professionals with disposable income, tech-savvy individuals in well-connected cities, people with disabilities who can afford premium services, large corporations seeking to reduce labor costs. Who is left behind? Marginalized communities face systematic exclusion from EV benefits. Low income individuals unable to afford expensive technology. Rural communities with poor infrastructure. Elderly populations uncomfortable with new technologies. And over 3.5 million professional drivers facing job displacement. The next is equity considerations. The technology threatens to exacerbate existing transportation inequalities, public transit defunding as private AV adoption increases, digital divide creating mobility gaps, environmental burden shifted to manufacturing communities. Let's move on to the next topic, which is ethical and sustainability trade-offs. Environmental benefits are reduced emissions through optimized routing, electric vehicles integration, and decreased private car ownership. The manufacturing impact here is massive resource extraction for batteries, rare earth mining, and electronic components with significant environmental costs. Risk distribution. Who bears the risk of algorithmic failure? How do we ensure accountability for life and death decisions? And finally, moral dilemmas. Reduced emissions through optimized routing, electric vehicle integration, and decreased private car ownership. Let's move on to the next topic. Personal reflection, engineering responsibility. So, transform perspective. This analysis has fundamentally changed how I view engineering. I now see that technical excellence without social responsibility is incomplete. Every design decision has human consequences that extend far beyond the immediate user. Professional responsibility. As an engineer, I have an ethical obligation to consider who might be harmed by my innovations, not just who will benefit. This means actively working to include marginalized voices in the design process and advocating for equitable technology changes. Next is product lifecycle assessment, environmental cost, raw material extraction, lithium mining for batteries. Sorry, devastates local ecosystems, consumes 500,000 gallons of water per ton, and creates toxic waste in developing nations. Manufacturing phase, semiconductor production requires ultra pure water and generates hazardous chemicals. Each AV contains 2 to 3 times more electronics than conventional vehicles. Operational use, while operation may be cleaner, increased vehicle miles traveled due to convenience could offset emissions, benefits empty repositioning trips, and inefficiency. End of life disposal. Complex electronic waste stream with limited recycling infrastructure, lithium batteries pose fire hazards and require specialized disposal facilities. Okay. So the question is not whether we can build autonomous vehicles, but whether we should build them in ways that serve all of humanity equitably and sustainably by critically engineering reflection. This reflection has personally taught me that engineering is not just about solving technical problems, but also about making choices that shape society. Every line of code, every design decision, and every deployment strategies carries moral weight. As engineers, we must embrace this responsibility and work actively to ensure our innovations serve the common goal. Good. Thank you very much. Do drop your suggestions in the comment box on how will you ensure your engineering work serves all members of society.